Hallo, Deusie van. Oké. I use sometimes AI, but it's usually a waste of time. So I'm starting to use it less and less because I learned over the last years that it just doesn't do anything useful in terms of saving time. On the other hand, I think I kind of learned when an AI can give a reasonable answer, or that if I have a certain question that I know that it can answer, then I use it. Yeah, and then still it fucks up often, but. Okay, what was I doing? I want to edit this one, I think. I need something like this. This before the break. 16 more lines. Well, let's shift them back. Still. Send visit. Yeah, or don't do a visit here. What is this doing here? Iter and nothing. Probably should I rewrite this. Child positions is an array of board with a number of children valid values. And here I need to check if it's copying that again. So this does look good. So I need to check if new board is in child positions. Why would I go through index? Probably the default. And then it probably won't be end. It's probably going to be equal to this. Ridiculous. No, excusez-moi. Didn't help, of course. I can't compare boards. Insanity. No, strange. Look at friends. I think the size is 9 times 9. It's just right. I did not want to see this, alright, I'll wait for it. How long does this take again? A minute, I think. Might as well wait for it now. There it is. Why to move made in 73 ply. And then if I do an illegal move like King B2, then it should tell me. Illegal move, great. And I do a move, I believe the only right move here is King of Rook F4. So we put the rook all the way up here, and then it should not be mate anymore. Curious, F9. It prints this, probably not what I want to print, but yeah, that means that it is a draw now. Your last question, you say, do you have any tips for us improving programming after having already learned a lot but being stuck in solid clean code? I don't think I understand the question. The being stuck part, how do you get stuck? Get completely stuck, you should start a rewrite. Start over. Okay, what I was investigating is the following. The maximum number of ply is apparently one less than what is printing. I'm going to manually update it. Not that it matters much, but still. Right. So beginning at a board of 9 by 9, the maximum number of ply that fits on that board is 73. 10 by 10 is 82. From that moment on, there is an interesting pattern. 11 by 11 is 10 more ply. 82 to 92. 12 by 12 is again 10 more ply. 13 by 13 is again 10 more ply. 14 times 14 is again 10 more ply. 15 times 15 is Again, oh, 8 multiply. Why? So that's the question. Why is it every time 10 multiply, and then what is special about 15 times 15? After that we get 16 times 16 is again 10 multiply, 10 multiply, 10 multiply, and 8 multiply. And so on. In other words, this grab here. And that's all the data I can get. Should probably divide it by 2. Apply ECD. Now if I knew Python, I could just read this as input and then divide it by 2. I can probably do that in Bash as well, but I have no idea. Now we have a nice thingy where you can ask an AI. Because AIs can do this kind of stuff. Let's ask ChatGPT. I have input like this. How do I convert that to a list of the same integers but all divided by 2 from the command line on Arch Linux? And AWK, okay. Awesomeness. No, I never can remember that. The online encyclopedia of, there was an integer database, but it's not it. I'll just type it in full. Online database of integer sequences. Okay, what is it? O-E-I-S. I cannot remember that. It has no space. Okay, let's remove the space. Let's remove the 36.5 is not an integer, so let's leave that out. So what I'm going to do, not match anything in the table. Yeah, I think we have a clear case of not knowing. Can be anything. Maybe with a lot more data. There was something, but by that time I can even guess it myself. Let me think. Probably shouldn't print that anymore. The printing. You've got to be kidding me. Oh, I left that in, of course. UTF-8 odd. Hmm. Probably all the way up. Rook F9. Nope. Draw. Can't do a go back. Should just probably print all moves that are possible, that are optimal even. Why is this not highlighted? Is it called something else? Right, a square. Okay. No matter how much do this, there's so much other things that can go wrong. Could be an illegal move and I would still print it, or multiple pieces could be changed. So I'm gonna just assume that you only call this when it makes sense. I do need 2 though. We go till 32 easily. You're gonna be fucking kidding me. That is the function that I just wrote. Get move is a standard string. A function of board given to board. Why is it commented out? Oh, because this is version 1 stuff. Might as well use the real type here. No exclusive OR. So I'll use a get value. We have a size type. hell? Well, div is non-zero. The black king moved. So the black king first, and then the white king, and then the rook. So the black king moved because this changed into that. The rest is the same. Oh, the black king mask is not shifted. What bloody file is this, man? Yeah, ports. And it is totally shifted. What the hell? Oh, I should have used mask. What? Am I not using mask? I am using mask. Totally using mask. Now getting confused. The white rook, shifting the white rook mask. That's nonsense. Oh, I'm looking at the wrong version again, as usual. Version 2, yeah, okay, that's not shifted. Why is it not shifted? Am I even using this thing? I'll just have to shift it. No, it's being used and an assert and here, which shifts it, so maybe I should just shift it. It's very, very, very big. Larger than this. 16 million, that is like way, way, way bigger. Why? Does this make any sense? Seriously. Okay, it's too big. Let's call it uninitialized. B is uninitialized. But why? It runs over all child positions. Oh, that's probably not a good idea. Yeah, that's nonsense. I think this is an array. So we have a number of children here, yeah. And that is probably 0 or something. 4, well, okay. Quit, yes. Board. Where did it go wrong? Let's go here. 699. That's not even the file. What file is this? Here. The VI. And we should have run over all the children by index. Possible optimal moves. King e2. Rook f7. Do I did that one correct? There's only one move. King e3. Now we can choose king a3 or king b3. Interesting. Let's play as bad as possible. King a3. Now we can go towards the white king. King d4. Yeah, let's play king e4. And now we really have to go to the b square because king b4. Still we can go towards the king. I'm gonna go up. King e5, king c5. If we had taken the other route, then we would have been forced to go up now. In the end we just end up here anyway. Enter move for black. King e6. We can still go up, attack the rook. Rook j7. Was that where I put it? Or did I accidentally put it at i7? Oh, I put it up. Yeah, that's what I did. Rook j7. I put it on f9. That is the correct move. And now we get king f5. Wow, that is the most annoying move. King f5, not king f6 for some reason. Super interesting. And now we can play rook j6 or king d6. Rook j6, go one down. Let's go king d6. King f6. King d7. Wow, what the hell? King d5 or d6. King e8 or king e7. Okay, let's try 7. To the H file, 5 or 6. Oh, there's also a 10. Yeah. Yeah, of course, the board is 10 by 10. Rook j4. 4, 3, 2, 1. It's all good. Yep, and the king is cut off. Well, that was very complex, if you ask me. Let's go on autoplay. So do not get a move from the user, simply hi Haysom. Yep, I'm recording in C++. Let's see. Possible moves. Do I want to print that? No. No, well, no. Let's print all the moves, but then not ask the user to do a move. Let's use a fixed algorithm. So I'm gonna run over all the children. And then we find one that, so again we get a board, and I need of course my info, and we need the child, apply, and then we will only consider it if it is an optimal move. And then, of all those optimal moves, we're going to pick the one that is the most, going the most, I don't know, difficult. Need some kind of position sorting, I suppose. I think simply sorting on the encoded value is going to work, because that stores, we have only one block, so it stores the y coordinate of the black king and the most significant bits, followed by the x coordinate of the black king. So the black king, if moved, is wanting to go as high as possible, but then also as far as possible to the left. To the right, I mean, which is what I was after. Same thing for the white king, and then the white king, move the white king up or to the right is preferred over a rook move, which is also what I wanted. And then finally the least significant bits are rook moves, which then prefers to go up, and if that's not possible, it goes to the right. So yeah, we are looking for the largest encoded value. I'm just gonna use the index, I guess. The info index, and I want to do a compare. I can make an info index. If I use the default constructor, it's going to give me something that is constructed as -1. But then if I ask for the get value, I get size type as -1. So this is a super large value. I don't want it. I want to have a negative value here, and then go for the largest value. So I would have to work with sign type, or a special case the fact that it is -1. also known as undefined. Let's special case it. So we get here, and II is undefined, which hopefully is a member function of the vector. Well, vector index, yep. Returns true if the value is -1. Then we always do that, yes. But you also do it if the new value is larger than the current value by get value. So something is larger than II get value. And that then is the get value on the index that belongs to the child position. That is B as index dot get value. But then again you ask yourself, do I really have to call get value? Because surely info index itself, aka vector index, has a larger than defined. It doesn't. Interesting. Oh, it does. Yeah. Yep. Larger than, less than, both defined. Already compare the value. The underlying value. The underlying value is a size type, which is exactly what we return. So might as well not call those member functions. Zip. Zip. So in that case, we set we set II equal to the B index, a new board. And we get the largest one in the end then. The largest one, that is the most optimal play. And it's the same as an end. Let me just add it like that. And then we want to do this, and then new board, they just set board to new board. And then we go to the next one. So we get the info for the new board. It's printed, but then break out of it if it is made. So if board, that's where you need the info of the board. Have that info. Classification dot is made. Then we're done. Which breaks out of this loop. It breaks out of the program. Hopefully. Well, it doesn't even compile. Yeah, probably just do that here. Ding, mate. That were a lot of moves. So I need to understand what goes on. So maybe I should not go this fast. Kid? I don't know. I don't know. Compiles. Okay, so now it is black to move. Black goes there, white cuts it off. Come running with the king. Go as far as possible. King goes up as high as possible, and then the rook goes in that direction, and then we cut off the black king just in time. And then we give mate the optimal way. No, I'll do that again so I get an idea what the hell happens. Yeah, those first two moves are kind of super special. Are they not? Well, now it's logical. Black can only go up, and white wants to walk diagonally. And as soon as the rook is attacked, then we just move it out of the way to the edge of the board, such that black can only follow the direction perpendicular to it, because the king is lagging, well, in both directions. Why is white now first? Oh, because he can also go up still. Moving the rook up didn't work. Then you just walk after the fact, or you can walk like diagonally. You cannot really walk like diagonally. This king is in the way. So because the king is like on the left-ish of the black king, you want the black king to move that direction. Otherwise, you can't go diagonally. If you would go up the rook, then the black king is going up as well, and then you can't go diagonally, because then this square's taken. So now white can keep going diagonally, but it couldn't there. But that's not a problem, because the black king didn't do the most optimal move either that it had. Or did it? Oh no, I'm confused. Here it goes straight up. What? No, I didn't, sorry. Yeah, we went there. Diagonally. I just use the hashtag, which is an pre-compiler directive, to comment out my code. Tempo move. Yeah, well. Now it takes 10 more ply. Still black to move, still in check. Seems to be flipped really. It's not nice. It ends in the same way. Yeah, I think it's more or less a noise generator. Probably shouldn't give it too much thought. Why? Why there is a difference at some point? It does start the same way, doesn't it? Plays the same way. Seems the white king is always starting at b1. And then we have the black king here on f2 in check at j2, which is 3 squares in between. So 3 squares, black king, 3 squares. And then one larger we have 1, 2, 3, 4 squares. And 1, 2, 3 squares. And the time before that, let's scroll off my scroll buffer. That maneuver is the same every time. This looks the same. And then I guess this is the same as well. At least at some point it's going to be the same. Not really actually. Doing something special there. The ending is the same again. One, two, three. Looks like every time the board is one bigger, the king and the rook just shift one square up in the starting position. And it's always doing that, and always that, always that, always that, always that, always that. And this also always the same thing. And because it was one further, we get one higher because you do this dance. Yeah, it is basically the same. And then we always go there, and then we always cut it off in time. And then what is different? There's already something different between 14 and 15. Between 14 and 15 it's only 8 more ply instead of 10. I'm going to try one more, and well, the maximum fits in my memory. 32 these times. which is going to take a few minutes. Yeah, taking longer than I thought. Yeah, there we are. I think that is. Not even sure what I did. Or rather, what it still has to do. I suppose it still has to calculate the whole graph. which might again take more or less the same time. I think a bit less time though. So version 1 could not get beyond 16 times 16. And this one, version 2, cannot go beyond 32 times 32. I tried 33 times 33, I'm out of memory. I can squeeze in, combine the number of ply with the classification bits, squeeze them in 2 bytes instead of the 3 that I need now, or 4 even. It's kind of used for the way it is now. No, 3 bytes, sorry. And therefore, black to move and white to move, that's 6 bytes each times the number of positions at all. So 32 is what's 32 to the power 6, right? Number of positions, that's 1 billion times 6 is 6 gigabyte. That's what it's using now. Kind of strange. Why would I run out of memory with a single bit more? Or is it 64 gigabyte here? Confused. 2, 3. Yeah. Well, calculator says 64 gigabyte. Why would it say that? I need light. I can't even see my calculator. Yeah. Empty line. Why is there an empty line here? And these A's should be, these B's should be A's, I mean. And they should stand above it, really. Or you read it for me on it. A, B, A, C. Okay, fed up with it. Shall I just stop with this whole project? Just one step away from actually answering my own question from the chess stick chess, whatever. Should at least try to answer that, I suppose. But yeah, and stop for today.